Hey everyone, welcome to Math 106, Section 5.2, Part 2. Up till now, we've been working on conversions that require one or maybe two conversion factors. Now we're going to work on a few that require more than two conversion factors. First one, we're converting 196,486 seconds to days. Now there's no one conversion factor that goes from seconds to days. In fact, there's no two conversion factors that will do it. We're going to need to trace a path from seconds to days. So we're going to go from seconds to minutes, minutes to hours, and then hours to days. Start off as we always do, the starting quantity with units over 1. First conversion is seconds to minutes. Make sure you position it so seconds on the bottom. So we got 60 seconds. Units will cancel here in 1 minute. All right, now we're at minutes. We're going to go from minutes to hours now. So 60 minutes, 1 hour. And the minutes on top, minutes on the bottom cancel. Finally, we want to go to days. So we got 24 hours in 1 day. So we got it set up correctly because all the units are gone that we don't want, and we're left with units we do want in the numerator. Now we're going to multiply straight across on top, 196,486 times 1 times 1 times 1. And on the bottom, we're doing 60 times 60 times 24. And that is 86,400. Units are days. Finally, divide this out, get 2.3. So 2.3 days. Door share number 1. 1 week to minutes. How many weeks are there? How many minutes are there in a week? Just a reminder, I'm not going to stop the video, so just pause it, work through the problem, and then restart the video. All right, starting the quantity 1 week, put it over 1. All right, now we're going to go from a week, 1 week, to 7 days. Weeks are going to cancel. Weeks on top, weeks on the bottom, those are gone. All right, now look at your table. We need a conversion factor from days to hours. Probably know that one already. All right, 24 hours in a day. Days are on the bottom, so they cancel with the days on top. Now we're going to go from hours to minutes. So 1 hour, 60 minutes. Hours cancel on top and the bottom. We're left with minutes on top, exactly what we're looking for. So we got it set up correctly. On top, we're going to do 7 times 24 times 60. That gives us 10,080. Multiplying straight across on the bottom, those are all ones. So we got 1. So that is 10,080 minutes in 1 week. Some weeks seems like there's a lot fewer. Part B, 200 teaspoons to cups. Symbol for teaspoons is T. So 200 T over 1. Now we're going to go from teaspoons to tablespoons. We got to trace a path from teaspoons to cups. We're going to go from teaspoons, tablespoons, and then to fluid ounces, and then to cups. So 3 steps. There are 3 teaspoons in 1 tablespoon. Teaspoon for tablespoons is capital T. For teaspoons, tablespoons is capital T. Teaspoons is little t. All right, now we're going to go from teaspoons to fluid ounces, and tablespoons to fluid ounces. So 1 fluid ounce is equal to 2 tablespoons. All right, so there's our next conversion factor. All right, make sure we're getting these units to cancel correctly. Teaspoons on top and the bottom, tablespoons on top and bottom. Now we're at fluid ounces. So we're going to go from fluid ounces to cups. That conversion factor is 8 fluid ounces. All right, 8 flaws in 1 cup. Now let's multiply straight across. 200 times 1 times 1 times 1, 200 on top. And on the bottom, 3 times 2 times 8. So that's 6 times 8 or 48. We got 48 on the bottom, and fluid ounces cancel, so our units remaining are cups, exactly what we're looking for. So that is great. 200 divided by 48, and that is 4.2, rounded. So 4.2 cups in 200 teaspoons. All right, next up, we're going to do area and volume conversions. And below you can see the tables. We've got some conversions already calculated out there. And we're going to see how those are calculated in just a second. Now, units of area. Areas are measured in square units. So if we measure, let's say, feet on the side and feet on the other side, we're going to multiply those using the area formula, and we get square feet. Feet times feet is square feet. And a couple different symbols there. We got SQFT, or feet with a 2 exponent. And square miles. All right, we got miles times miles, we get square miles, or miles squared. Now, if we do conversions with areas, in square units, they appear twice. So that means if we want to convert square units, we have to convert them twice. We do a double conversion. So let's see where these area conversion factors come from. So in example 2, we're going to find the conversion factor between square feet and square inches. And we're going to do that by converting 1 square foot to square inches. So a square foot is, another way to write this is feet times feet. Now you don't have to do this, I'm just doing this for demonstration purposes. And that means since we have 2 feet, we need to get rid of both of them. And we're going to use 2 conversion factors to do that. All right, 1 foot, 12 inches. And then we'll write it again, 1 foot, 12 inches. And there are different ways to write this. It can be done with 1 conversion factor if you square everything in the conversion factor. But again, for demonstration purposes, I'm just going to write it twice. And now we've got feet that will cancel here, and feet that will cancel here. So the feet are gone, and what units are we left with? We've got inches times inches. And inches times inches is inches squared, or square inches. So that's exactly what we're looking for. Multiplying straight across, 1 times 12 times 12, that is 144 square inches. Multiplying across the bottom, it's just 1. So that's 144 square inches. And that's the value that you see in the table. So that's where those values come from, by doing a double conversion. So try that out. Your turn number 2. Find the conversion factor between square yards and square feet by converting 1 square yard into square feet. So you got 1 yard squared over 1. Now we're going to multiply by 1 yard is equal to 3 feet. And then do it again, 1 yard, 3 feet. All right, yards squared, there's 2 of them. So we're just going to cancel both of those. And we're left with feet times feet, feet squared. Multiplying straight across, 3 times 3 is 9 feet squared over 1. So that means 1 square yard is equal to 9 square feet. But you don't have to do that. You can use the conversion factors from the table. All right, this is just to show you where they come from. So next example, we're going to use something from the table now. Example 3, we're going to convert 0.15 square yards to square inches. And there's the square yards. And now the conversion factor from the table, we have 1 square yard is equal to 1296 square inches. So now we only need one conversion factor because we're doing it all at once. Square yards cancel. Multiply straight across 0.15 times 1296, and that gives us 194.4. Multiplying straight across the bottom, we get 1, so that is 194 square inches. And that brings us to your turn number 3. Convert 1,278 square feet to square yards. All right, we're going from 1278 square feet to square yards. Now, the conversion factor, if you check out the table, all right, we got 9 square feet, that's the one we just found. It's equal to 1 square yard. All right, multiplying straight across, that is 1278 over 9. Divide that out. You get 142 square yards. So using those conversion factors from the table will save us a step. Now units of volume are in cubic units. So with any volume, we've got 3 dimensions to it. Right? Length, width, and height. So that means we're multiplying, let's say we're measuring in feet, feet times feet times feet. So that is feet to the 3rd power, or cubic feet. Now, the procedure for solving conversion applications. So that's what we're going to be doing next. And these application problems are a little bit different because we're not just going to be relying on conversion factors from the tables. There are going to be conversion factors built right into the problem. So we're going to have to read through these descriptions and pick out conversion factors that will be useful for this problem. So example 4, we've got a washing machine, requires 4.2 gallons of water to fill. If the washing machine fills at 153.6 fluid ounces per minute, how many minutes does it take to fill? So step one, we're going to identify the starting quantity and the desired quantity. All right, so we're given the total capacity of water is 4.2 gallons. So there's our starting quantity. Since it's not a rate, we're just going to write it over 1. Now, there is a conversion factor built into this one, and that is the rate, 153.6 fluid ounces per minute. Remember, per is the divisor line, so that gives us a rate, fluid ounces on one side of the divisor line, minutes on the other. But notice we're given gallons, and that rate's in fluid ounces. So one thing we're going to definitely need to do is get rid of that gallons and convert it to fluid ounces. So let's do that first. 1 gallon is 128. Oops. Fluid ounces. All right, now we've gotten rid of gallons. Now we're at fluid ounces. So now we can use the next conversion factor. We can use the rate given in the problem. Since we have fluid ounces on top, on this rate, we're going to put the fluid ounces on the bottom. 153.6 fluid ounces per minute. So that's per 1 minute. So 1 minute goes on top. Fluid ounces cancel. Those are gone. Now the question is asking for how many minutes does it take for it to fill? So there's our desired quantity. Only quantity left is minutes. So we've got it set up correctly. All right, multiplying straight across. 4.2 times 128 gives us 537.6. And on the bottom, 153.6. Dividing this out, the units are minutes. Divide this out and we get 3.5 minutes. So it takes the washing machine takes 3.5 minutes to fill. So make sure you include 3 pieces of information in your answer. Numerical quantity, 3.5, the units, minutes, and what we're talking about, filling the washing machine. Your turn number 4. A homeowner is planning to purchase new carpeting. After taking measurements of the house, total area of the carpeted rooms is found to be 1,200 square feet. If the carpeting costs $21 per square yard, how much will it cost? All right, so let's identify starting quantity and the desired quantity. Starting quantity, size of the carpeted rooms, 1,200 square feet. And the desired quantity is dollars. How much is it going to cost? So we're going from square feet to dollars. Starting with the starting quantity, 1,200 square feet over 1. However, the rate given in the problem, the conversion factor, is $21 per square yard. And we have square feet. So first thing you need to do is convert square feet to square yard. So 9 square feet, 1 square yard. All right, now we're at the right units, square yards. Now the next conversion factor is the one from the problem, and that is $21. 1 square yard. Okay, let's make sure all our units cancel. Square feet, square yards, square yards. And we're left with dollars. That's exactly what we're looking for. Now we can multiply straight across. 1,200 times 21. That gives us 25,200 dollars. And multiply across the bottom, we get 9. Divide that out. And we get $2,800. The carpeting costs $2,800. All right, next example. The circumference of a circle is the distance around. Now with an automobile tire, that means one revolution of the tire as the car goes forward means the car travels exactly the circumference of the tire. So that tells us how far the car is going to travel each revolution. If the circumference of the tire on a vehicle are 102 inches, how many miles will the vehicle travel if the tires make 5,000 revolutions? All right, so the tire is going to go around 5,000 times. How far does the car go? So starting quantities, 5,000 revolutions. Ending quantity is in miles driven. We're going to start off with 5,000 revolutions in a starting quantity. I'm going to abbreviate rev for revolutions. Now we know that the circumference is 102. So that means for every one revolution, we're going to travel 102 inches. So there's the conversion factor built right into the problem. And so that gets rid of revolutions. Revolutions cancel. And now we're at inches. But we don't want the distance in inches, we want the distance in miles. So now we need to convert inches to miles. A couple different ways we can do that. We can go from inches to feet, and the feet to miles, or inches to yards, yards to miles. And I'm going to do feet. So that means 12 inches and 1 foot is the first one we need to go from inches to feet. Now we're going to go from feet to miles. So that is 5,280 feet in 1 mile. Feet on top, feet on bottom, those cancel. All the units are gone except for miles, and that's exactly what we were looking for. So we have it set up correctly. Now multiplying straight across, 5,000 times 102. That gives us 510,000 on top. Miles. And on the bottom, 1 times 1 times 12 times 5280. That is 63,360. Divide out, and we get 8.0 rounded. So 5,000 revolutions of the tires, we travel 8 miles. Your turn number 5. A driver participating in a dirt track race is estimating how much fuel will be consumed in the race. Each lap is 660 yards, and there are 50 laps in the race. If the car gets 3 miles per gallon, how many gallons of fuel will be used? All right, so we can see a rate in there, 3 miles per gallon. And each lap is 660 yards. So 660 yards per lap. So there's 2 conversion factors built into this one. And we're starting with 50 laps. So your turn, 5, 50 laps. We're going to convert a number of laps into a number of gallons of fuel. So first thing we want to get rid of laps. So let's use that first conversion. Each lap is 660 yards. So 1 lap, 660 yards. Now the other rate is in miles per gallon. So that means we need to get rid of these yards because we can't use these. We're going to have to go to miles. So there's 1760 yards in 1 mile. All right, laps cancel, yards cancel. We're at miles. Now we can use that other conversion factor, 3 miles per gallon. Make sure you put 3 miles on the bottom and 1 gallon on top. That way, miles on top, miles on bottom, cancel. And now all the units cancel except for gallons, and that's what we're looking for. So we're good to go to multiply straight across. 50 times 660. That gives us 33,000 on top, gallons. And on the bottom, 1760 times 3, that is 5,280. Finally, we'll divide 33,000 by 5,280 and get 6.25 gallons. So the car will use 6.25 gallons of fuel. Oh, forgot to answer the complete sentence here. Vehicle will travel 8.0 miles. Yep. Example 6. Now in this one, our starting quantity is itself can be a rate. So that can be a little confusing. Easy to confuse the starting quantity with the conversion factors. It's helpful to start with the starting quantity, but multiplication is commutative. If I had switched these around, I'm still going to get the same answer, because it doesn't matter if I multiply 3 times 1760 or 1760 times 3, I'm still getting 5,280. And the units will still cancel. So if you're a little confused about which is your actual starting quantity or which one's a conversion factor, as long as you can get the fractions to cancel correctly and give you the ending units, you're going to get the right answer. So don't get too hung up on starting with the starting value if you can't figure it out. Just get the fractions to work out. Now it's helpful to start with the starting quantity because then you can be guaranteed that you got your fractions oriented correctly. If you don't start with the starting quantity, you may end up having to make a change later and flip a fraction over and do stuff like that. So it's more complicated that way, but you can still get the right answer. That's one of the great things about this technique. So water is a major cost in the textile industry, which is clothing production. A textile factory pays $5 for every 1,000 gallons used. If the factory uses 50,000 gallons of water each hour, how much does the water cost the company each week? And we're going to assume that the factory runs every day, so a 7-day week. Now, we've got a cost rate, $5 for every 1,000 gallons used. But what we're really starting with, what we really want to convert is the amount of water they're using and converting that into dollars. So the starting quantity is 50,000 gallons of water per hour. Now, one thing we're going to have to convert for sure is hours into weeks. And then we also have to convert gallons into dollars. All right, we can get rid of gallons right away. So 1,000 gallons is $5. All right, gallons are gone. And now basically what we have here is dollars per hour, but we don't want dollars per hour, we want dollars per week. Okay, hours and hours, cancel. Now we've got dollars per day. We're almost there. 7 days. In 1 week. All right, now days on the bottom, days on the top, cancel. And now our units are dollars per week. And that's what we're looking for. So 50,000 times 5 times 24 times 7. And it gives us $42,000 on top, and on the bottom, that's 42, whoops, skipped a step there. Went right to the answer. That's $42 million over 1,000. And divide these out, and we get $42,000. So, cost of the factory, $42,000 per week for water. Your turn, number 6. Part A, a server for a large web hosting company scans pictures for viruses that have been uploaded by users. The server can process 200 megabytes of data per second. If the pictures being uploaded average 3 megabytes each, how many pictures can be processed by the server each hour? All right, so our starting quantity is the amount of data that the server can process. So what we want to do is figure out if the server is processing 200 megabytes per second. We're going to convert that to pictures per hour. All right, so we want to convert megabytes into pictures. And the conversion factor given the problem is each picture averages 3 megabytes each. So 3 megabytes in one picture. All right, megabytes cancel. So what we're at now is pictures per second. We don't want pictures per second, we want pictures per hour. So we're going to convert seconds into hours. So 60 seconds on top and 1 minute. All right, now we have seconds on bottom, seconds on top, those cancel. Now we're at pictures per minute, so that's good. One step closer, so 60 minutes over 1 hour. And are all set up to multiply straight across 200 times 1 times 60 times 60. And that is 720,000 over 1 times 3 times 1 times 1. So 3 in the bottom. And that is, see, minutes cancel, pictures on the top, and hours on the bottom. Finally, divide the two numbers out, and we get 240,000 pictures per hour. So the server can process 240,000 pictures each hour. All right, part B. Contractor is considering starting a business and would like to estimate the cost of operating company vehicle to visit job sites. Contractor visits an average of 3 job sites per week and drives an average of 35 miles to each job site. That's round trip. If it costs 75 cents per mile to operate the company vehicle, find the cost per month. And we're going to assume that there are 4.33 weeks in a month. That's 52 weeks divided by 12. All right, so we've got several different conversion factors built into this problem. All right, each job site requires 35 miles of driving, so 35 miles per site, there's a rate. We've got 4.33 weeks per month, there's another rate. You got 75 cents per mile, there's another rate. So what we're trying to do is we're trying to convert 3 job sites per week into dollars per month. Dollars per month. So our starting quantity is 3 sites per week. Our ending quantity is dollars per month. All right, let's get rid of the sites. We don't care about sites, we want miles. So 1 site is 35 miles. All right, sites are gone. Now we're at miles per week. We don't care about miles, we want to get dollars. So let's convert miles into dollars. And we know that we're going to be paying about 75 cents for every 1 mile in total vehicle costs. All right, that gets rid of miles. Now we got dollars. All right, now we're getting really close now because we have dollars per week. And now we just need to get to dollars per month. And we're given that we have 4.33 weeks in 1 month. Weeks cancel. All right, so remember you can cancel across any fraction. Obviously it's on the top and bottom. And now we are ready to go because we're at dollars per month. That's exactly what we're looking for. We're going to multiply straight across. 3 times 35 times 0.75 times 4.33. And that gives us 340.99 if we round. And on the bottom, we're just multiplying ones all across there. And the units are dollars per, I'll just put 1 month on the bottom. So that is $340.99 per month. So the estimate for vehicle cost is $340.99 per month. Part C. Now I looked this stuff up on a forum, on a welding forum, and I think I got the type of calculation correct. I don't know if and some of the numbers I know are correct, like the density. But as far as how much it takes per weld, I was kind of making that stuff up. So I don't know if these numbers are particularly realistic, but I know some of them are. So a welder does some calculations, some volume calculations, and we'll see how to do those later on. And determines that a certain weld requires 2.7 cubic inches of steel weld material. Now those are welding rods for a certain type of welding, stick welding, or I think they call it. And the rods have a density of 0.284 pounds per cubic inch. If 14 welds are required to complete the job, and each welding rod weighs 0.4 ounces, how many rods are required to complete the job? All right, so what we're trying to convert here is the number of welds into the number of rods. All right, we're doing a certain number of welds, we don't know how many rods we need. So, starting with 14 welds, assuming they're all the same size. And now, we're estimating that each weld requires 2.7 cubic inches of weld material. So we can convert one weld into 2.7 cubic inches of steel welding material. All right, so welds are gone. Now we're at cubic inches. We're also given the density. So 0.287 pounds in 1 cubic inch. So 1 cubic inch and 0.287 pounds. Oops, 2.284 pounds. Now we're getting there, but the rod weight is given in ounces, and our density is in pounds per cubic inch. So that means we're going to have to convert pounds into ounces. So 1 pound, 16 ounces. All right, let's check our units now, make sure we're doing all right. We've got cubic inches on top and the bottom, those cancel. Pounds on top and bottom, those cancel. So we're at ounces. So we're one step away now, because we know that each welding rod weighs 0.4 ounces. So now we're going to convert ounces into rods. All right, 0.4 ounces in 1 rod. Ounces on top, ounces on bottom, those cancel. All right, we've gotten rid of all our units except rods, and that's what we're looking for. So 14 times 2.7 times 0.284 times 16. And that is 171.76. And on the bottom, 1 times 1 times 1 times 1 times 0.4 on the bottom rods. Divide this out and get 429 rods. And from what I read on the forum, there's about 42 per pound. So that's about 1 10-pound package worth of rods. And if there are any welders out there who see any problems with this, let me know. I'd like to make sure these problems are as accurate as possible. All right, everybody, have a great day.